Alright, so this is a video editorial for the LeetCode Biweekly Contest 177. The problems this time were decent, they were fairly well balanced. I think Q3 was the hardest problem in this contest. Q4 was a basic math problem, and Q1 and Q3 2 were trivial. You can see me make this silly mistake because, like, for some reason I don't know what I ate, but for some reason I had to go and take a shit mid contest, which is why I couldn't think straight. Obviously, like, it's hard to think straight under literal pressure, but yeah, so I had to go to the. You can see this during the live solve, by the way. I had to rush to the washroom mid contest, but whatever. Yeah. So I'll be going through the solutions in the order they are presented, and I'll be sharing the solutions I implemented. And after this, after my explanations are over, I'll also add the live solve section. Alright, so Q1 was basically we are given an array, and for every pair of distinct values x and y, so x has to be unequal to y, x has to be less than y, and such that x and y have different frequencies. We have to choose a pair such that the value of x is the smallest, and if the value of x's are the same, then the value of y has to be smallest, and we have to return this pair, right? So here 1 and 3, 1 is the smallest value and 1 and 3 have different frequencies, right? 2 and 3 is also a valid pair, but 2 is greater than 1. So again, this is for the constraints for both num's length and num's height less than equal to 100. So for 100 I was like, okay, straightforward, this can work. What do we say? N square can work. So first we can calculate the frequency of all the elements in a map, and then we can enforce. Sorting will help us enforce this rule. Basically find the smallest, this first x, and if x's are the same, then we find the smallest y. Sorting can help us enforce this. And now basically for I for j loop, if this isn't required, by the way, if the elements are the same, then the frequencies this condition will by default break. So basically for some pair, sorting has ensured that we are iterating on the smaller x's first. Yeah, so for some pair, basically first, this isn't even n square actually, because first we'll find the value and then we'll find the next value if it's different. I mean, it's n square in some worst cases, but you can easily optimize this by making this into a set instead, but whatever. By pruning out distinct values, like if this were for 1e5, you can first calculate the frequency, then get a distinct values, and then run this loop. So basically this loop, what this loop is doing is, we first basically for some pair, if the frequencies are different, then the elements are also different. If frequencies, yeah, I mean, you get the idea, right? Basically we need to just check this, and if it's different, we return nums I comma nums j, and at the end, if there are no pairs, we return -1 -1. Earlier during the contest, I also had that check. I also had this check because I was literally solving the problem. This nums I unequal to nums j, because x has to be less than y. But this will, if this is true, then this can never be true. This is always true, right? If frequencies of two elements are different, then the elements are obviously different. So yeah, so moving to problem 2. Yeah, this was a problem during which I had to shit, which is unfortunate. I couldn't even read the constraints. My solution is O of n. I solved this problem for O of n, so whatever. The idea is we are given a string s, and two equal characters in the string are close if the distance between them is at most k, right? And when two characters are close, the right one will merge to the left one. So basically here, A and this A are close because this is index 0, this is index 3, and 3 minus 0 is 3, so they can merge. So this becomes ABC, right? This merges into this, and so on. And after merging, the indices will get reassigned. So here, like in this example, this and this is less than equal to, this is 0, this is 1, so distance is less than equal to 2, right? So this will merge, so this becomes y. So all of these indices will decrease by 1, right? Since this element is removed now. And of course, not of course, basically these merges, we have to merge the leftmost pair. So for this, basically my idea is I can maintain a map which will have the nearest, what do we say, the nearest index, the latest index for every character. And if that character's index exists, and if I'll explain this thing first, and if it's within range, then we'll remove this. Else, if it's outside of range, then we have to update the index, right? Because we want the nearest character. So we'll update this. Now what is this rem? Who's rem? What is rem? So what rem is basically, now the thing here is, n is less than equal to 100, so you can easily simulate this process, like actually do the removals, but that is not required. So my solution here was, I'll take this example, y y b y z, y b z, right? Y y b y z, y b z, I guess z, yeah. So what the play is, assume since and k is obviously 2, so we can do this removal. Right, since the distance between these indices is 1, which is less than equal to 2. So after we can, what the observation we can make is, after we remove this, all of their indices will decrease by 1, right? Instead of this 2 will become 1, because this string will shift here, this will become like this. So all the indices will decrease by 1. My bad. Yeah, this will become 6, this will become 5, 4, yeah, 3, 2, 1. So this index went from 2 to 1 and whatever, so on. So for this, whenever I am removing something, I am incrementing this, and now the actual index is, instead of I, it's I minus rem. Since here after one removal, the index went from 2 to 1, right? So again, assume we did some other removal here. Now here we can see that this is also a valid removal, right? So again, this we'll do rem, since 2 removals will happen, rem will become 2, and this index will become, this will again get reduced by 1, right? So from 4 this will become 2, which would be the correct index, since if this were removed and this were to be shifted here again. So I hope you can understand this basically like a sort of lazy idea. I am tracking the actual removed index using this rem thing, and the map is basically the latest occurrence of every character. And yeah, this solution is O of 1, which is very fast, considering the input was 100. But yeah, Q3 was very interesting in my opinion. Like I taught the idea fairly quick, but I couldn't, like, I had some implementation mistakes, and my, like, this was again, as I stated, I had to go to shit, right? So my mind, I wasn't thinking very straight, but yeah, whatever. Wait, my rank change. Yeah, not bad. So yeah, what was I saying? Basically, we are given an array, and alternating parity basically means that odd, even, odd, even, or even, odd, even, odd, basically alternating and whatnot. And the operation described to us is either increment num psi by 1, or we can decrement num psi by 1, right? And we have to return an answer where answer 0. First of all, the first thing should be the minimum number of operations to make the parity the array parity alternating, right? And if there are multiple answers with the minimum this possible, the other thing should be minimized. So basically in this case, we want to minimize basically the spread, basically the distance between the max element and the min element. And this has to correspond to this. So this is kind of similar to the first problem, how we are returning the answer. This was x and y, so here similarly first minimize this and then minimize this. Now some observations. We are dealing with parity. If you think about it, there are only 2 possible arrangements of the answer possible, right? Either it's let 1 be odd, since it's parity this, and 0 be even. Either one possible arrangement is 0 1 0 1 0 1 0 1 dot 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 and so on, and the other possible arrangement is 1 0 1 0 1 0 and so on. There are no other arrangements possible, right? If you think about it, like you can try making some other arrangement. If you're starting from 0, then the next element has to be 1, since the problem states that it has to be alternating, right? So yeah, this was my first, not even observation, my first idea. This is a fairly common idea when you have to make stuff alternating, that only 2 possible arrangements are possible, 2 valid arrangements are possible. So first, now since it's 2, we can just try solving for both, right? Like it will be some O of, let the solution complexity be f for 1, let f or whatever, then this would be 2 of f of x, right? So we can just try solving for both of these possible arrangements. So what I did was, I made some function which solves for one such possible arrangement. So now how to solve for one such possible arrangement? Let's try handling the first part first. This problem might seem daunting since it asks us to minimize both the things corresponding like to each other. So like initially my very first idea was to use some sort of DP, but then I was thinking how would I do this, right? Minimize both of them according to each other. So then I swapped to this idea instead with the fixing of the two answers. So assume we are trying to solve for some this arrangement 0 1 0 1 0 1, right? And we have an array with this parity 1 1 0. I'm only writing the parities right now. I'll take this example only. -2 -3 1 4. -2 has parity 0, -3 has parity 1, minus what? 1 has parity 1, and 4 has parity 0. This is the parity, right? So since we can either add or subtract 1, right? We can either do plus equal to 1 or plus equal to -1. This means in a single operation we can flip the parity. So whenever the parity is different from our suggested thing, we can just do the operation and flip it. So here it will take us 2 steps, right? If we are trying to align it to this, if we are trying to align our input, this is our input, to this arrangement, and if we try the other arrangement 1 0 1 0, it will again take us 2 steps, since we would have to flip this part. So like for this, the thing is, you can iterate on this all I. Whenever this is basically just a fancy way. This is for checking the parity, and this is for checking what my desired parity was. So basically how I wrote this function is, it takes the obviously input array and some even and odd, right? This even and odd is basically telling the arrangement. So this is the 0 1 arrangement, and this is the 1 0 arrangement. And how I coded it was, I put this in a array of size 2. So if I pass 0 1, then we would be following this arrangement 0 1 0 1 0 1, and if I passed 1 0, then we would be following the other arrangement, because I am accessing the current required value using another parity thing inside this. This is just some implementation tricks. These are not that important. You have to understand the idea first, right? So okay, the first part, let us assume we have, we have solved the first part. We know the minimum number of steps. Now we need to minimize this as well. The spread, the values. Now if we assume we have some array like this, this is our array, right, where these are representing the values. What do we say? The magnitude, like this is a lower value and this is a higher value. To minimize this max minus min, what we want is, we want to squish these values close, right? Now one observation here is, let the current max minus min be some k, right? What I'm saying is, the answer can never go less than k minus 2. This is because as in the operation for minimizing the number of steps to make our array alternating, what we noticed is, at every element we would only either do the operation once if it doesn't match with the prescribed parity, or we won't do the operation at all, right? So here, since we can only do the operation once, in our best case what would happen is, our max value would get reduced by 1 and our minimum value would get increased by 1, which would make the answer our original max minus min, and again minus 2. So this was my first observation which I got. So leading on to this, now what I did was, my idea was to also, this is a very, my solution is, I'm pretty sure this might be or might not be the intended solution, but this solution is fairly ad hoc-ish. What I did was, I marked all the elements which are to be flipped, regardless whether they would be flipped. By flipped I mean which are to be done, we have to do this operation on. So I just marked those elements. So now my idea is, I would try to do this, what I described here. I would try to lower the maximum value and increase the minimum value, right? So I got the minimum and maximum value in this, what do we say? In the array I got the minimum maximum value, and if the current value was flipped and it was the maximum, then I'll try to decrease it, since it will bring it closer. Because the thing is, since we are doing +1 and -1, right, both of these are guaranteed to flip the parity. And now since I have a maximum value and I want to bring it down anyways to reduce the spread, I'll just decrease it. Like, I hope you understand this part, that +1 and -1 are doing the same thing to the parity, and since I want to minimize the spread, bringing it down is bringing the value of the maximum value down is the better choice. And similarly for the the minimum thing, bringing it up is the better choice. So you can just do this. The other values now, the thing is, assume we have, obviously these values can also be flipped, right? But the thing is, these won't never affect the answer since we are only operating upon +1 and -1, and this operation is only done once. This would never affect the answer. You can try enumerating on all of these cases. So after this operation we get the actual, this is the initial min and max, this is the after this operation min and max, we get the spread and we return this. And now from both of this we lexicographically minimize this and we return the answer. This was Q2. Honestly, I found this problem more interesting than Q4, sorry, this was Q3. I found it more interesting than Q4. Alright, so Q4 was a cool problem, I'd say. It was a math problem, mostly a math problem. Basically what we are given is, we are given a range L to R, which means we can access digits from L close interval to R, and obviously this is 0 to 9, right, between this range. It could be like 1 to 3 or whatever, basically 0 less than equal to L, less than equal to R, less than equal to 9. Yeah. Okay. Now for this, and we are given K. Now what we want to do is we want to find the number of numbers. We actually have, like for some, let's say this example, I'll explain with examples only. K is 2, L is 1 and R is 2, right? So K is the number of digits in our number and L and R is the range of the digits. So for L equal to 1 and R equal to 2, any 2-digit number where the digits are between this range would be valid. So here let's say 1 is a valid number since it's a 2-digit and the digits are in this range. 2 is a valid number, 2 is a valid number, but obviously 2 is not valid because we have more digits. 1 is also not valid since it has less digits, and 33 is not valid because like the digits are not in this range. So we have some set of numbers. My bad, sorry. We have the set of numbers. Now for this specific set of numbers, what we have to do is we have to find their sum. So why is this not moving? What? Yeah. So here all these were the possible numbers and their sum is 66, right? So yeah, the answer is 66. And here this was the possible, what do we say, the possible arrangements, and their sum is 444. So basically we have to do this. And now obviously the thing is, K is this, the number of digits is less than equal to 1e9. So one can't possibly, do a digit DP or some sort of thing here, because you cannot have a number as large as 1e9 in your state, right? So now the other intuition, obviously initially I was reading this problem, I was like, okay, digit DP L to R something. But then I saw K is less than equal to 1e9, so my mind switched, my mind skipped that idea and it went to math. Since now that is when you're dealing with 1e9, math is the only possible solution, right? Or you could do some like login thing, but yeah, I'll think about math first. So now, assume we have some numbers. Let 0, 9, 2, 4, or whatever. Leading zeros are also valid here, so assume we have this number. First of all, how many possible numbers are there? The thing is, for k digits and for for R and L, we will basically have R minus L plus 1 raised to the power k digits, right? Since for the range L to R, we have R minus L plus 1 choices, like for 1 to 2, we had 2 choices, right? 2 minus 1 plus 1. So here this can take R minus L plus 1 choices, this can take R minus 1 plus L choices, and so on. For all the k1s, we will get this R minus L plus 1 raised to the power k. So this is the number of numbers we have. But we don't want the number, we want their sum. Now for the sum, my idea was, I went the contribution method, right? Assume we are dealing with this digit 4. Let all of the other numbers be scrambled right now. These are not these, let these be like whatever values. We are thinking about 4. So how much is 4 contributing? How many numbers is this 4 contributing, first of all? Since we have logged this, we have k minus 1 numbers remaining, right? we have k minus 1 numbers remaining. So this 4 is contributing to r minus l plus 1 raised to the power k minus 1 numbers, right? This one should be clear since we have locked this, and all of these k minus 1 number have r minus l plus 1 choices. So yeah, this much is done. And now how much is this 4 exactly contributing? This is the ones place, this is the tens place, hundreds, thousands, and 10,000, right? So this 4 is contributing 4 into 10,000, and this is, let this be some x. This is contributing 4 into its place, 10,000 actually, 1 more 0, yeah, 4 into its place value, I guess 4 into its place value into the number of digits, right? This is the total contribution of 4. Similarly, 5 would also contribute this much, 6, and all of our digits L to R would contribute this much, right? At this place. Now if we move one step left, so some digit y would be contributing, this is 10,000, so it would be contributing 100,000, right, into the same number of places. So here we can observe some pattern. This part is remaining fixed, Rx, r minus l plus 1 raised to the power k minus 1 is fixed. So we can put this in some variable as a constant, as I did here, x. Now obviously we can't iterate again, right? Since k is less than or equal to 1e9, we can't possibly iterate here. But if we observe some pattern, here first we have the ones place, then we have the tens place, hundreds. So if you look at these places here, we have this, right, 1, 10, 100, and so on, right? So basically, like if we lock some digit y would be contributing 1 first for this, then it will be contributing 10 for the next place, then 100, and so on. And this would happen, and this contribution will go into all of our x digits, right? This much digits. Now this we can observe as a GP, a geometric progression, like where a is our first term, which is equal to 1, and r is our common ratio, which is 10. So and we have, let's say, k terms. Do we have k terms? Yeah, we have k terms. So a sum of a GP with these values is a into r raised to power k minus 1 by r minus 1, right? This is a standard formula, like I was taught this in school, which is why, like, during the contest I didn't even have to look this up. I remember I had this in my mind. So we can do this to get this value, then we can multiply it for some yi, where yi is in the range L to R, right? And then we can again multiply it with our x. So basically we just have to return this sum, right? And this r power k for some large k can be found using binary exponentiation. And since we are doing stuff mod 1e9 plus 7, this multiplication and subtraction and basically all other operations have to be modulo our thing. So yeah, this was the problem. Basically it was kind of if you know this and some math. So this is what I did. Actually, I don't think I even need this now. I was doing something wrong first. Let me resubmit just to be sure. 66444. Yeah. So basically, what I'm doing is, first of all, I'm storing the sum of all y's, right? Since these are all multiplication operations, we can, instead of iterating on all y and doing this again, we can just take this and this common and get the sum of all y's, right? So we get this is the sum of all our yi's, which is in y. We get this x. What is x now? X was this r minus l plus 1 raised to the power k minus 1. So yeah, r minus l1 was plus 1 raised to the power k minus 1, and obviously mod these are standard functions. Rn is this thing. In our GP, we do this, right? Rn minus 1 by r minus 1. Yeah, this thing. Our first term is always 1, so that's not required. So this will give us this. Now we need to do Rn minus 1, right? And since we are doing subtraction, I use the proper subtraction formula for mod, and then I'm dividing it by 9. So this is modular division. Now you do y into x. Y was the sum of all yi's, and x was the number of elements to which it will contribute. And then we multiply it by this. r n, which is 10 raised to the power k minus 1 by 9, right? And this is our result. Again, this was more of a math problem, but yeah. Alright, so this was my solution. If you like have some doubts or something, you can ask in the comments or whatever. I'd say like Q3 was the most interesting problem. I could have performed like way better, but yeah, whatever. Again, after this, I'll add my live solve section where you can see me trying to solve these problems, like how I was thinking, why I was thinking, live during the contest. And again, you can see me rush to take a shit during the Q2 solve as well. Alright, bye. Phone guy, just in case I find something. 177 problems. Okay, no. 6 pointer, 5 pointer, 4 pointer, 3 pointer, 6 or 7 pointer नहीं है ये क्या है? DPR. So that's done by different frequencies. इसका राउट है okay, हाँ. One three one one. I see क्या है. ऐसे नहीं होगा तो डिस्टेंस चेंज हो जाएगा ना उसमें. स्टार्ट टाइप होगा. What? ABC, why ABC? Took too much time here. Huh. What? Wait a second, what? I ये क्या हो रहा है भाई, मुझे पेट दर्द हो रहा है यार, फक। अबे यार, जाना पड़ेगा। अबे यार, मैं क्या कर रहा हूँ? और नहीं पड़ेगा यार, ये तो मैं जल्दी से आके आता हूँ। शिट। This is very unfortunate. This is very unfortunate. This is very unfortunate. So less than equal to 100 you answer. What? जैसे मान लो टारगेट है स्मॉलेस्ट है मुझे उनमें 5 लाना है ना इसके बाद जब मैं कर सकता हूँ रेक स्टेप्स तो कर सकता हूँ ना ऑड इवन हो गया हाँ ठीक है इसमें मुझको क्या मेन मेरा ये है मेन इंक्रीज होगा मैक्स स्पीड होगा 3 4 3 है ठीक है 3 5 3 है चॉइस है आंसर भी देख नहीं मुझे ये सेट कर देना k less than equal to 189. Huh? Wow. Number of digits अपना वही है k power r minus r plus 1. सम बताना है इनका सम कैसे होगा सम बाइनरी एक्सपेंशन टाइप हो मैट्रिक्स आई तो है ना another count of numbers here. किसी नंबर की कॉन्ट्रीब्यूशन कितनी होगी इसे फिक्स कर लो है ना Ten into 20 plus 40 plus 6 ठीक है सब्ट्रैक्ट करके ऐड करूँगा और ये मैं प्री कैलकुलेट कर लूँ नंबर ऑफ नंबर्स है ना तो ये होगा अपना k minus 1 k minus 1 raised to power r minus n minus 1 plus 1 ये होगा फैक्टर नंबर ये सब में उल्टे लगा तो बाद में से लगा ले x अपना इधर से जाना मैं ये l से r का भी सम निकाल लो ठीक है ये भी निकल गया अपना l से r का सम ये ले रहा y और z है अपना 1 plus 10 plus 100 तो ये हो गया अपना क्या होता है a r n minus 1 by r minus 1 ना और सही है x है अपना k minus 1 raised to the power is equal to 1 के अलग से हैंडल करना पड़ेगा मुझको. Y plus equal to ये टर्म्स होता है 1 10 और 100 है ना 1 on 1 ऐसा ये क्या है अपना 3 है ना 3 टर्म बना था हाँ ठीक है raised to the power of k more. running next guy. Dude. वाई अपना वही होगा 3 होगा वैसे पीछे जो है गलत तरीका सही गलत तू क्या है ये 1 क्यों है अरे fuck my bad shit अरे यार I